All right, section 9.6 is on solving rational equations and inequalities. This is the last section that we do in chapter 9. Notice I skipped 9.5. That's fine, I do that a lot. You guys just don't realize I do that a lot. So I didn't find it important, so we skip over it. All right, so it says in order to solve rational equations, we multiply each term of the equation by the least common denominator. Okay, so here's some basic problems. So you might have done this in Algebra 1. Some of you have, some of you will have never seen this. It's okay. All right, so when I see this, number one, there's two approaches you can go with the problem. You could change all of your denominators so that they're the same thing. So if you do that, what denominator would you make them? 12. Okay, so this would be what I would call the long way. So you don't have to write this. So the long way would to change everything to 12. So that 1/2 you'd multiply by 6 over 6. The negative x over 6 you'd multiply by 2 over 2. You'd get x over 12 plus 6 over 12 equals negative 2x over 12. You're solving for x, right? So you'd subtract the x over 12 over. So you'd have negative 2x minus x, so negative 3x over 12. And then you get to this point where you have a fraction equaling a fraction. Do you guys remember what you could do from here? You could cross multiply. Okay, you could also multiply by 12 to clear the fractions. All right, so when you cross multiply, you'd end up with 72 equals negative 36x. Oops, negative 36x. So you'd get x equals negative 2. All right, kind of a long process. You're dealing with fractions throughout. And a lot of you guys have fraction phobia, and you don't like fractions. So we need to try to find a way to avoid fractions if possible. All right, so we're going to try to avoid them if possible. So we're going to do what I call the shortcut. So the shortcut is to recognize what your common denominator would be. So your least common denominator would be 12. And you're going to take that 12 and you're going to multiply by your entire equation. So the way I always write it is I just take my whole equation and I put brackets around it. And I put a 12 on the outside, which is kind of weird. We don't usually write it that way, but yeah, 1 over 2, thank you. So I take the entire equation from before and I multiply it all by 12. Okay, think about what this is saying. It's saying every single term is being multiplied by 12. Okay, so when you guys get used to these, I don't want you to write this step, but I'm going to write it just for your notes so you can see what's happening. So we're taking 12 and we're going to multiply by the first one. We're taking 12, we're going to multiply by the second one. We're taking 12 and we're multiplying by the last one. Okay, think about what this is saying. So if I have 12 times x over 12, what's canceling? The 12s, right? This is like 12 over 1. So whenever you have something on top and bottom, you can reduce or cancel. So the next one? Yeah, it becomes 6. So the 2 cancels. We have 6 on top now. The last one, 12 and 6 reduced to 2. So what you really have is 1 times x, right? So it's just x plus 6 equals negative 2x. This is a much easier equation. It doesn't involve any fractions at all. We've now cleared all of the fractions. Subtract the x over, you get negative 3x equals 6. So you get x equals negative 2. That's your answer. So let's do the same thing on this next one. So if I was going to get a least common denominator, what would my least common denominator be? 8. So that's if I was going to go the long way. All right, so I'm going to take my entire equation and I'm going to multiply through by 8. So once again, I'm going to show you the step. Oh, yeah, I write this a couple different ways. So I think the first way I did it was like this, right? Oh, whoops, 7/8. So I just put like brackets around the whole thing or parentheses around the whole thing. You can think of multiplying by 8 on both sides, though. All right, so when I do this, I'm going to have 8 times x over 4 plus 8 times 3 equals 8 times 7/8. Once again, when we get really good at these, we're not going to write that step where we write out each thing times the 8. So think to yourself, what's canceling for the first term? The 8 and the 4 reduce down, and you're left with 2, right? So you'd have 2x. On the next one, we just have 8 times 3, which is 24. And the last one, the 8 and the 8 reduce, so we just have 7. Okay, easy equation. Subtract the 24 over. You get 2x equals negative 17. So x equals negative 17 over 2. And that's your answer. So question, could you guys do that from this step? So if you're thinking in your head that you're multiplying by 8, are you canceling in your head? So 8 times x over 4 would make 2. Don't cross things out if you're going from that step, because 8 is not completely canceled for the rest of it, right? Do you guys see how that works? So it's only, you're kind of doing it in your head and you're saying, oh, the 8 and the 4 reduces to 2, so I have 2 times the x is left, so 2x. The next one, 8 times 3 is 24. The last one, the 8 and the 8 would reduce down. 8 and 8 would cancel, so I get 7. Okay, so can you do that in your head? Okay, so let's try it on the next one. It's a little bit harder. Okay, what is the least common denominator on this one? X squared minus 9, because that is x plus 3 times x minus 3, right? Okay, so what I'm going to do is I'm going to take my x plus 3 and my x minus 3, and I'm going to multiply by the entire equation. I guess I'm saying that kind of funny. I'm taking that x plus 3 and the x minus 3, and I'm multiplying it into the entire equation. Okay, do you guys see why it's convenient not to write out the step where you multiply x plus 3 times x minus 3 by everything? It gets really long, right? So let's see if you can do it in your head. So think what's canceling for each piece. So on the first one, when I have 1 over x plus 3, on that one, the x plus 3's cancel. But I'm telling you, don't draw those little marks through like I just did, because it's still there for the next one. Andrew, does that make sense? Okay, so we're not going to draw the little marks. You're thinking in your head those x plus 3 and the x plus 3's cancel. So if you want to take your hands and put them over, so, pretend this is my hand. I'm putting it over those terms. Do you see what's left? Just the x minus 3, right? Okay. On the next one, I have x squared minus 9. Well, that is x plus 3 times x minus 3. So now I'm covering up both pieces. So all that's left for that middle term is 5. And on the last one, think what you're covering up with your hands. X minus 3 and x minus 3. So those cancel. Do you see what's left? Yep, 2 times the x plus 3. So you could write 2x plus 6, or you could write 2 times x plus 3, like that. Doesn't matter. Okay, do you guys need to see the long step written out? No, you get it. Okay. So this is x plus 2 equals 2x plus 6. I'm going to subtract the x over. So I get x plus 6 equals 2. Subtract the 6. So I get x equals negative 4. That's your answer. Now I will say be very careful on these, because if you look at number 3, notice how there's x's in the denominator? That means there's places where it's undefined. So if you'd gotten 3 as an answer, and you went back to check, do you guys see what would happen? So if 3 was your answer and then you went back to check, you'd have 3 minus 3 here, which would end up being no solution. Okay, so if there's an x in the denominator, you need to go back and check your answers. Okay. In this case, it would be okay. It's not giving us undefined. All right, the next one. Okay, this is where it gets a little tricky again. I've told you this kind of factoring always messes people up on this test. Do you guys see what I'm saying by this kind of factoring? What do you need to do there? Pull out the common factor, which is just 2. Okay, that means that this other one would be missing a 2. The 1 over x minus 2, you'd be missing a 2 on the denominator. So your least common denominator is 2 times x minus 2. So I'm going to have 2 times x minus 2, and I'm going to multiply it by the entire equation, so x over 2 times x minus 2 minus 2 equals 1 over x minus 2. Oops, that's weird x. So I took the least common denominator, I'm going to multiply by everything in the equation. Okay, on the first one, are you thinking what you're covering up with your hands? Yeah, what's going to cancel is the 2 and the x minus 2 on both of them. So you'd have x left. On the next one, we don't have anything on the denominator, so I'm going to need to multiply by the 2 times x minus 2. So I have the negative 2 from before times 2 times x minus 2. And the last one, the only thing that's canceling is the x minus 2's. So I have 2 times 1, so I get 2. Okay, this middle part might look a little weird for you guys. If that's fine, just do the 2 times 2 in one step, which is 4. And then multiply by the x minus 2 in the next step. So I'm going to have x minus 4x plus 8 equals 2. So I get negative 3x plus 8 equals 2. Negative 3x equals negative 6. So x is 2. If you go back to check, this is what I was talking about. You'd get 2 over 2 times 2 minus 2 minus 2 equals 1 over 2 minus 2. Do you see how that's not working out? You get 2 over 0 minus 2 equals 1 over 0. That's all undefined. So that means that 2 could not be a solution. So we write no solution. So occasionally that will happen where the answer you get is what we call an extraneous solution. It's an extra solution that when you go back and check, it's not going to work. So that means there's no solution. All right, you guys try number 5. So try number 5. All right. So when you look at your denominators, this is x plus 1 times x minus 1 when you factor it. So that means that's what you need your least common denominator to be, right? So that's your LCD. So I'm going to multiply x plus 1 times x minus 1 by the entire equation. So this is allowing us to clear the fractions. All right, so on the first one, so I'm taking my fingers and I'm going to cover up the common factors. So x minus 1 and x minus 1 would be common factors. So all I'd have left is the x plus 1 and the 4. So I'm going to have 4 times x plus 1. Okay, then on the next term, x plus 1 is in common. So I'm going to have negative 2 times x minus 1. And then on the last one, x plus 1 and x minus 1 are the common factors. So I'm left with just 35. So when I multiply out, I get 4x plus 4 minus 2x plus 2 equals 35. So look for your mistakes, those of you that didn't get 29 over 2. It was probably on the distributing. So you're going to have 2x plus 6 equals 35. Subtract the 6, so you get 29. Divide by 2, you get x equals 29 over 2. Now if you go back to check, the only answers that would give you no solution are if you had 1 or negative 1. Okay, if you had 1 or negative 1 as answers, when you go back to check, you would get undefined because of the denominator. Okay, so 29 over 2 will work.